Good day, everybody. How are you all? Today we are going to discuss random variables. So here I go. So as I told you, we are going to discuss about random variables. The word random particularly means without any preference, without any order. And variables comes from the word vary, which means a characteristic that vary from person to person or from object to object. So these are my objectives. So first we will distinguish between discrete and continuous random variables. If we roll a fair die, the possible outcomes are numbers 1, 2, 3, 4, 5, and 6, as shown here. Each of these numbers has a probability 1 over 6. Rolling a die is a probability experiment whose outcomes are numbers. The outcomes of such an experiment is called a random variable. A random variable is a numerical outcome of a probability experiment. Okay. So it's called a random variable because before we roll the die, we do not know which number will land up, face up. Okay. And it is a numerical outcome, means it's a number that results from a probability experiment or a chance experiment whose results we do not know before doing the experiment. Discrete random variables are random variables whose possible values can be listed. Examples include the number that comes up on a roll of a die. We know it can be either 1, 2, 3, 4, 5, or 6. Or it can be number of siblings, brothers or sisters that you have. Either you have 0, 1, 2, 3, etc. You count and you list. You cannot have a fractional brother or sister such as 0.5. So from 0, the next number will be 1. Okay, that's why it's called a discrete random variable. Continuous random variables are random variables that can take on any value in an interval. Examples include the height of a randomly chosen college student. Why it is continuous? Because first of all, we measure the height. Next of all, it can be anywhere from between 5 and 6 feet in that continuous range. The amount of electricity used to light up a randomly chosen classroom, it is measured by a meter. Okay. Determine the probability distribution for a discrete random variable. A probability distribution for a discrete random variable specifies the probability for each possible values of the random variable. So what are the properties? The first bullet says the probability of the discrete random variable x is between 0 and 1. The lowest value is 0, highest value is 1. That means probability cannot be less than 0 or greater than 1. Less than 0 means it cannot be negative. Greater than 1 means it cannot be 1.2, 1.3, etc. And sum of all probabilities is 1. What is a good example of that? Well, we know when we toss a coin, the probability of getting a head in the long run is 0.5, and probability of getting a tail in the long run is also 0.5. So probability of head plus probability of tail, because these are only two outcomes, possible outcomes when we toss a coin. Hence, probability of head plus probability of tail is 0.5 plus 0.5 equal to 1, which meets the requirement of the second bullet. Sum of the probabilities of all possible values of x is equal to 1. A fair coin is tossed twice. Let x be the number of heads that come up with. Find the probability distribution of x. You're tossing a coin two times, okay? So you can get both heads. Number of heads is 2. You can get the first one head, second one tail. Number of heads in that situation is 1. You can get the first one tail and the second one head. Number of heads in that situation is 1. Or you can get both the coins land tail face up. In that case, number of heads is 0. There are 4 equally likely outcomes and the number of heads is indicated for each outcome. There are 3 possible values for the number of heads, 0, 1, and 2. One of the 4 outcomes has a value of 0, 2 have 1, and 1 has 2. Therefore, probability of 0 is equally likely is 1 out of 4.25. Probability of 1 is 1/4 plus 1/4 is equal to half. And 1/4 plus 1/4 is 2/4, which is half, which is 0.5, and probability is 2 is also 1 out of 4 of 0.25. Now in the table, the list the x values, the values of the discrete random variable and the corresponding probability. This list of the values of discrete random variable and the corresponding probability is called the probability distribution. Here in this case, lowest value of x is 0, then 1, and the highest value is 2, and the corresponding probabilities are listed. Notice if you add all the probabilities, you will get 1, which meet the criteria of the second bullet that we discussed in the last slide. Decide whether each of the following represents a probability distribution. The first probability distribution on the left has a negative probability. Probability cannot be negative. So this is not a probability distribution. The second one, we have to see whether they add up to 1. There is no negative probability value. There is no probability value greater than 1. So let's add the probabilities. 0.17 plus 0.25 is 0.42, plus 31 is 0.73, plus 0.22 is 0.95, plus 0.05 is 1. Hence, the sum of the probabilities is 1. This is a probability distribution. All the probabilities are between 0 and 1, and they sum to 1. Look at the one on the extreme right, that probability distribution. One of the probabilities is greater than 1. We know one of the rules of probability cannot be greater than 1. This is not a probability distribution. Probability of 1 is not between 0 and 1. 4 patients have appointments to have their blood pressure checked at a clinic. Let X be the number of patients that have high blood pressure. The probability distribution of X is, okay, 4 patients, X0 means nobody has high blood pressure, okay. 1 means 1 person out of 4 has a high blood pressure. 2 means 2 people out of 4, and so forth. And 4 means all 4 have high blood pressure. Now, if you add the probabilities, you want to make sure it is 1. So 0.23 plus 0.41 is 0.64, plus 0.27 is 91, 0.91 plus 0.08 is 0.99, plus 0.01 is 1. The events 2 and 3 are mutually exclusive since they cannot both happen. Okay. So we use the addition rule for mutually exclusive. P2 plus P2 or 3 means P2 plus P3. Why? Because 2 and 3, at the same time, 2 patients cannot have high blood pressure and 3 patients have high blood pressure. So they're mutually exclusive events. So P2 plus P3 is 0.27 plus 0.08 is 0.35. 4 blood patients have made appointments, same problem. Let X be the number of them had high blood pressure. Find the probability distribution of X is the probability distribution X is follow more than 1. More than 1 means 2 plus 3 plus 4, okay, which is 0.27 plus 0.08 is 0.35 plus 0.01 is 0.36. Okay, in this one, find at least 1. That means 1 and above. What is the complement or opposite of that? 0. Okay, so use the law of complement, law of the probability of complement events, okay, which is probability of at least 1. That means probability of X greater or equal to 1 is 1 minus probability of 0, which is 1 minus 0.23, which is 0.77. A school teacher flips a coin and uses the result to determine whether to start the school day with a math lesson or a history lesson. If the first lesson is recorded for 3 consecutive days, there are 8 possible outcomes. MMM means all math. MMH means first 2 days math and then H and so forth. Assume these outlines are equally likely. That means probability of each event will be 1 out of 8 because there are total 8 possible outcomes. Okay, let X represent the number of days that start with a math lesson. How many days start with a math lesson? I can see 1, 2, 3, 4. Okay. So Let X represent number of days that start with a math lesson. How many days start without a math lesson? 0. And that is H, H, H. So its probability is 1 out of 8. How many days start with one math lesson? And there are two of those, two or three of those actually, three of those. MHH, HMH, and HHM. 3 days, three have at least one math lesson. So one math lesson is 0.375 because it's 3 out of 5. How about how many have two math lessons? And that's equal to MM2, just two. Okay, MMH, MHM, and HMM, 3 out of 8, 0.375. And how many have three math lessons? Only one, MMM. 1 out of 8 is 0.125. If you add this probability, so here X means how many math lessons are there in those 3 days. 0 means no math, which is H, 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 1 out of 8. Hence, his probability is 0.125 and so forth. Okay, if you add these probabilities, you get 1. In each case, determine whether each of the following represents a probability distribution. So we are looking whether the sum, we're looking for the fact some of the probabilities have to be 0, has to be, has to be 1. Some of the probabilities has to be 1 and nothing should be below 0. Here we do not see any negative probability that is below 0, so we are fine on that. How about the sum of the probabilities? 0.45 plus 0.15 is 0.6 plus 0.3 is 0.9 plus 0.1 is 1. Hence, the top left sum of the probabilities is 1. Therefore, this is a probability distribution. How about the second one? 0.02 plus 0.41 is 0.43 plus 0.24 is 0.67 and plus 0.33 is 1. It's fine. Second one on the top right is also fine. How about the third one? On the bottom, 0.27 plus 0.15 is 0.42 plus 0.11 is 0.53 plus 34 is 0.87 plus 0.25 is greater than 1. So the one on the bottom is not a probability distribution. Following the probability distribution of a random variable that represents the number of extracurricular activities a college freshman participates in. So they can participate in 0 activities or maximum of 4 activities. Find the probability that the student participates in exactly 2. Exactly 2 is 0.45. Find the probability that student participants in more than 2. More than 2 means 3 and 4 added together. So 0.21 plus 0.14 is 0.35. Find the probability that the student participates in at least 1. At least 1 activity means 1 and above. So the complement or opposite of that is when the student participants in 0 activity. Using the probability law of complements event, probability of 0 participation, X is equal to 0 is 1 or minus, student participates in at least 1 activity. At least 1 activity means 1 and above. So probability of activity 1 and above, you can add 1, 2, 3, and 4, or using the complement rule of probability, you will to find probability of X at least 1. From 1, you subtract the probability of the complement event, which is 0, because 0 is opposite to 1, 2, 3, and 4. 0 does not include 1, 2, 3, and 4. So 1 minus P of 0 is 1 minus 0.06 is 0.94. Same answer you will get if you add probability of x1 plus x2 plus x3 plus x4. That means at least 1. Okay. Describe the connection between probability distribution and population. Statisticians are interested in studying samples drawn from populations. Random variables are important because when an item is drawn from a population, the value observed is the value of a random variable. Okay, the probability distribution of the random variable tells how frequently we can expect each of the possible values of the random variable to turn up in the sample. So maybe we are looking for people's age. So age is what is of interest, and probability of each age means how many times it will appear. The probability distribution of random variable, if it is age, tells how frequently we expect each possible value of the age, random variable is age, to turn uh, in the sample. So parking facility contains 1,000 parking spaces categorized as follows. They have given the cost, and they have given the number of spaces. A parking space is selected at random. Let X represent the hourly parking fee for the randomly sampled space. Find the probability distribution of X. Okay. So how did they do it? $1.50. There are 423 of those. 428 out of the total. $2 space, there are 140 out of the total, which is 1,000. $4 is 57 space out of 1,000 spaces. It's 0.057. And $4.50 is 378 out of 1,000. It's 0.378. So here the random variable is the parking fee in hours. Lowest value is 150. Highest value is 450, in between a 2 and 4. Okay. Often when we draw a sample, we compute the sample mean X bar. The quantity X bar is a random variable because its value is different for different samples. The probability distribution for X bar is usually difficult to compute. We will learn a way to approximate the probability distribution of the sample mean when the sample size is large in a later chapter. There are 5,000 undergraduates registered at a certain college. Of them, 478 are taking one course, 645 taking two courses, 568 are taking three courses, 1,864 are taking four courses, 1,357 are taking four courses, and 88 are taking six courses. Let X be the number of courses taken by a student randomly sampled from this population. Find the probability distribution of X. So X value varies from 1 through 6. Okay. So X, the lowest value is 1, highest value is 6. When X is say 1, the probability of X equal to 1 course is 478 divided by 5,000. When X is 2, probability of X equal to 2 is 645 divided by 5,000. How about probability of X equal to 6 is 88 divided by 5,000. So these are the values that you get by taking the number of students in each of the category of courses. One course, for example, is 478 divided by the total 5,000 will give you 0.0956. Now construct a probability distribution for a discrete random variable. So here they're listing the probability distribution of the number of the following present the probability distribution histogram for the number of heads in a sequence of 5 tosses, using the assumption that heads and tails are equally likely and the tosses are independent events. They're looking at number of heads if you're tossing a coin 5 times. Okay, 0 can appear 0.03125 times, 1 is 0.15625, etc. So on the horizontal axis, as you can see, number of heads in 5 tosses. Lowest value is 0, highest value is 5. On top of each of these values of X, which is the number of heads, they draw a vertical rectangle. Point to note the width are the same. The heights of these vertical rectangles are different. Why? Because heights represent the relative frequency or probability. Therefore, the center, the height is the highest, which is when X is 2 or when X is 3, probability is 0.3125. Hence, the heights of those two rectangles are the same, 0.3125. Okay. The following presents the probability distribution and histogram. The one on the right, vertical rectangles with the heights represent the relative frequency of probability. And the bottom, same width, they are the values of that heads. that there is no gap between the adjoining or adjacent rectangles. This type of diagram is called a histogram, relative frequency, probability versus the values. Okay. Following is a probability histogram for a number of children a woman has. What is the probability number? Randomly chosen woman is exactly 2. So you look at 2 on the horizontal axis and the height of it is 0.244. What is the probability that a randomly chosen woman has fewer than 2? Fewer than 2 means 1 and 2. So you add those two probabilities up, or the heights of those vertical rectangles. 0.273 plus 0.16 is 0.433. What is the probability that a randomly chosen woman has either 4 or 5? Again, you add the relative frequencies or the heights of those vertical rectangles is 0.082 plus 0.39, which is 0.121, I believe. Compute the mean of a discrete random variable. Recall that the mean is the measure of the center. The mean of a random variable provides a measure of the center for the probability distribution of the random variable. Another name for the mean of a random variable is the expected value. To find the mean of the discrete random variable, multiply each possible value of x by its corresponding probability, then add the products. And that is expressed in this formula. Mu x, mu, as you know, is the population mean, is equal to sum of value of each value of x and the corresponding probability. Get all the products, add them up. The symbol is Greek capital S sigma, which means sum of the products of the value of x times its corresponding probability. A computer monitor is composed of a large points of lights called a large number of points of light called pixels. It is not uncommon for a few pixels to be defective. Let x represent the number of defective pixels on a randomly chosen monitor. The probability distribution of x is as follows. Find the mean number of defective pixels. So you have x varies all the way from 0 to 3 and the corresponding probabilities. You want to find the mean or the center of this probability distribution. So what do? You take each value of x, multiply its corresponding probability, then add all the products up. That is the way to use the formula. How to do it in the calculator? You press the second button on the top left, plus on the bottom right, then number 4, clear all list, hit enter, then stat 1. In X, you are going to enter, in L1, you are going to enter all the X values, which are 0, 1, 2, and 3. Now with the right cursor key, you put the cursor on the first line in L2. After you are done with 3, you enter the last value of X3 in L1 and hit enter, and then right cursor key to move the cursor on the first line in L2. So then you type the corresponding probabilities in L2, 0.2, 0.5, 0.2, and 0.1. Okay. Then you press the stat button, highlight calc on the top row, then number 1, where stats. List is L1, fine. First line L1 is fine. Second line, we have to tell the calculator that the frequency or probability, relative frequency is in L2. So after the colon in the second line, hit second and 2. Second and 2 will make it L2. And then bring the cursor down on calculate and hit enter. And the mean is 1.2 as they have obtained, which is the first line in the screen. Okay. If a probability experiment that produces a value of a random variable is repeated over and over, the average of the values produced will approach the mean of the random variable. When the probability experiment is sampling from a population, our interpretation of the mean says that as the sample size increases, the sample mean will approach the population mean. This is known as the law of large number for means. If we sample items from a population, then as the sample size grows larger, the sample mean will approach the population mean. Expected value, there are many occasions on which people want to predict how much they're likely to gain or lose if they make a certain decision or take a certain action. Often this is done by computing the mean of a random variable. In such situations, the mean is sometimes called the expected value. So mean is same as expected value is denoted by EX. If the expected value is positive, it is an expected gain, and if it is negative, it is an expected loss. Mineral economist estimates that a particular venture had a probability of 0.4 of a 30 million loss. Notice loss is minus X value at the loss, minus 30. Probability is 0.4. 0.5 probability of 20 million profit and 0.1 probability of 40 million profit. So what is the expected value? We can do it in our calculator. Second plus on top of enter on the bottom right, then number 4, clear all list done, then stat and 1. Remember in L1 the X values. The first one is minus 30. This minus sign, you have to be careful, is on the left of enter, on the bottom of the right bottom of the screen. So that minus sign next to enter. Press that and then 30, then 20, and then 40. These are the values in L1. Go to the top line in L2 by pressing the right cursor key, then 0.4, 0.5, and 0.1. These are the corresponding probabilities. We want to find out what is the expected value, that is the mean. So stat, calc, 1 where stats list is L1, frequency list is L2, calculate. And the mean is $2. 2 or $2 million, because everything is in million here. That is the expected gain. An insurance company sells a 1-year term life insurance policy to a 70-year-old man. The man says a premium of 400. If he dies 1 year, the company will pay 10,000 to his beneficiary. The probability that a 70-year-old man is still alive after 1 year is 0.9715. Let X be the profit made by the insurance company. Find the expected value of the profit. Okay. So in the first case, the insurance company is paying 10,000 to his beneficiary, but do not forget they collected $400 at the beginning of the year as a premium. So their actual loss for that situation is 10,000 minus 400, which is minus 9,600. Hence, it is not complete 10,000 loss, it is minus 9,600, and the probability of that happening is 0.0285. Okay. How did they get that? It is 1 minus 0.9715, because the probability the man is going to live after 1 year is 0.9715. So the opposite or the complement event of dying is probability is 1 minus probability of living after 1 year. So it's 1 minus 0.9715 is 0.0285. So let's again enter these numbers in the calculator. Second plus 4. Enter, clear all list done. Stat 1. Again, in the first situation, it's not a complete $10,000 loss for the company. It is 10,000 minus the 400 they collected. Minus 9,600 is the loss. So type the minus sign next to enter, then 9,600. Then the next one, they're totally gaining. The man is leaving, so the $400 they will totally gain. It's positive 400. Go to the top. The first one of loss is 1 minus 0.9715 is 0.0285. And they're gaining 400. That probability is 0.9715. And then you do stat, calc, 1, L1, L2, and calculate. So the expected value is $115. Okay. We interpret this by saying that the company sells many policies, same policies. It can expect to earn 115 for each policy on the average. Okay. Advanced AP exams are graded on a scale of 1 low through 5. The college board reported that the distribution of scores on the AP exams, stat exams in a recent year was follows. So X and PX are given. So second plus 4. Okay. So there, this is X is the grade. Lowest is 1, highest is 5. Okay. So stat 1 in L1, the X values 1, 2, 3, 4, 5. Go to the top of L2 and enter the corresponding probabilities: 0.32, 0.26, 0.16, 0.15, and 0.11. Then we do stat, calc, 1. X list is L1, while list is L1, frequency list is L2, and we calculate. So the expected value is 2.47. Okay. Compute the variance and standard deviation of a discrete random variable. So this is the formula. Remember, the variance is the square quantity. It is the square of the average distance away from the mean. That's why inside the parenthesis you have x, which is the number, minus the mean, and you squaring it, multiplying with the probability. Standard deviation is the square root of the variance. Okay, so let's do this in our calculator. So if you use the formula, it's a lot of calculation, so we will prefer calculator to calculate. So first is second plus 4. Clear all list, done. Stat 1. In L1, you put the x values 0, 1, 2, and 3. Go to the top of L2 and enter the corresponding probabilities values: 0.2, 0.5, 0.2, and 0.1. Okay. Now press stat, calc, 1 where stats, x list is L1, list is L1, frequency list is L2, calculate. And if you look through, you will get sigma x, the standard deviation, as 0.872. So how to get the variance from 0.872? It's not in the screen. So separately, we have to type 0.872 in the calculator and then press the x square button, which is in the first column halfway down, and we get the variance as 0.7603. Okay. So that's it for today. I will stop here today. If you have any question or comment, please write me a note. Please give me a thumbs up if you like the video. Please, I look forward to seeing thumbs up, many thumbs up. That really motivates me. And if you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button in the bottom right corner and hit the bell, because that way YouTube knows that you'd like to be notified every time I upload a new video, which I do quite often. Thanks for watching. Take care. Have a nice day. See you next time. And do not forget to watch me tomorrow when I'll be back with another interesting video. Take care. See you.